Okay, welcome to the video notes 8.4 about power rules, but not the notes section. Watch that video if you missed it. Go back and watch it first. But we're going to talk about two a little bit more complicated examples than we did before. So we're going to start with this number 7. And this is where exponents actually get to be a little bit of fun, if you're okay with the rules. So we're going to employ pretty much most of the rules that we've learned up to this point. We're going to break this problem apart. We're going to employ the power to a power rule, and the power of a product rule will also take place in here. And we've got some like bases that are going to be multiplied, and we're going to deal with some coefficients. So let's break it apart slowly and try to attack one piece at a time, remembering that these can be done multiple different ways, and that's fine. All right, so the first thing I'd like to do when I look at this problem is I'm going to go ahead and address this as two pieces. So I've got power to a power here, and I've also got here, which is including power to a power and power of a product. So I'm going to take this exponent and I'm going to multiply it to this exponent here, because that's what the rule says to do, power of a power. Okay, and I'm also going to do that here, but I've got three bases in there, and one of them has an exponent. So I'm going to break it apart and do those two things at once. So what does that look like? I'm going to get x to the negative 2 times 2, power to a power. That's going to be multiplied right here by this 3, which I'm going to separate out. But it's going to be multiplied, or it has to have the power of 4 here. So that's going to get 3 to the power of 4. X additionally will also get raised to the power of 4. And y will get the power of 4, but it has a 2. So power to a power says that they will be multiplied. So pause there, make sure you take a look at all those moving parts and decipher it. Okay? If you've had a second to look at it, let's start cleaning it up. If I look at this, I'm going to go ahead and clean up each individual piece before I do any more. So x to the negative 2 times 2 is going to be x to the negative 4th. Again, we're going to wait on the negative exponent right now. 3 to the 4th I could multiply out, but I'm going to leave right now just so I can see it that way. X to the 4th, there's nothing to complete or simplify on that. And then here I'm going to have y to the 2 times 4, or 8th. Now I'm going to use the commutative property to rearrange all of my terms here, or parts of my bases, in the right order. I'm going to move the coefficient out first, then I'm going to multiply it by one of my bases that I know I'm going to multiply together. So I'm going to have x to the negative 4th times x to the 4th, and then finally that y to the 8th. Now I've got everything arranged in order using the commutative property. So let's go ahead and take 3 to the 4th, which turns out to be 81. Okay. These two here, like bases being multiplied, if we remember that rule, we combine them under one base and we add them together. So negative 4 plus 4. And then again, we'll tag on our y to the 8th because nothing's occurring with that. Let's clean up that middle piece. So now we've got 81 times x to the 0 power times y to the 8th. Well, now we notice there's one left thing to do, which is x to the 0 power. Anything raised to the 0 power becomes 1. So we're going to be left with 81 times 1, which is just 81, times y, or y to the 8th. And we've cleaned it up from whatever we started with to a nice, neat 81y to the 8th power. Let's do that again. This one again is very similar. So same thing's going to apply here. I'm going to address both parentheses kind of at the same time. I'm going to address both of those. I'm going to realize there's a multiplication between them, right? Because that's how that looks. There's no addition or subtraction. And then we're going to rearrange them, use the commutative property, start combining using some of our rules, address any negative exponents, and we should be done after that. So the first part, I've got c squared raised to a power, which is power to a power rule, which tells me to take c and multiply my exponents. Then that's going to be multiplied to the next set here. And the 3 and the c are multiplied together, so they're both going to get the power of 4, power of a product. Okay, so I'm going to end up with 3 to the 4th times c. Now c has an exponent of 5, so this is power to a power. So I'm going to get 5 times 4. All right, let's clean this up a little bit. Let's clean our c's up. I'm going to get c to the 6th times 3 to the 4th times c to the 20th. All right, now I'm going to move my coefficient, or my number base, out front. So it's going to be 3 to the 4th out front times c to the 6th times c to the 20th. Now I'm going to go ahead and employ the like bases being multiplied together, and I can go ahead and multiply 3 to the 4th. We can do those together. That'll be 81. And then these will become times c to the 6 plus 20, because under multiplication, exponents add. and I'm going to get 81 times c to the 26th. Or I can even clean that up right there. 81c to the 26th. And we're done. Okay, so in this video set, you've seen us work through two main properties, which is power to a power, where we multiply exponents when they're raised to a power, and power over product, which says every base inside of parentheses that is raised to an exponent gets that exponent itself. We also additionally use multiplying like bases. We had some negative exponents in there, and we even employed zero exponent property. All right, so thanks for watching. We'll see you in the next problem.